Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in finding node having maximum sum of immediate children and itself in an n-ary tree. First, let us take an example. In this example, max sum node will be 4 with the sum of its children as 34. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, that is 1, to max sum function, so root will point to 1. We take a rest node and a max sum variable which we initialize to 0. Now, we pass the root rest node and max sum variables to the max sum util function. Since root is not null, we take an integer cur sum which will point to root's key. So cur sum will be equal to 1. Now we take a count variable which will store the number of children of node 1. Since 1 has 2 children, count will be 2. Now we run a for loop from 0 to count and add root's children's key to cur sum. So first 2 will be added to sum. Next we call the max sum util function with one's first child, that is 2, rest node and max sum passed as parameters using a call stack. Now as root is not null, we take a cur sum variable for root's key. So cur sum will be equal to 2 and count will be equal to the number of children of 2, that is 3. Again we run a for loop from 0 to count and first cur sum will be cur sum plus 4, that is the first child of 2. Next we pass the first child of 2, that is 4, to max sum util function along with rest node and max sum. So root will be 4. Since root is not null, we take a cur sum which will be equal to root's key, that is 4, and a count variable which will be 0 as 4 does not have any children. Now as count is 0, we don't enter the inner for loop and go to the if part. We check if cur sum is greater than max. As 4 is greater than 0, we set rest node to root and max sum to cur sum. So rest node will be 4 and max sum will be 4. Then we return to the previous call. Execution for node 2 is resumed and now we update cur sum to cur sum plus 5 and pass the next child of 2, that is 5. Now cur sum will be 5 and as node 5 does not have any children, count will be 0. As count is 0, we don't enter the for loop and check if cur sum is greater than max sum. As it is true, we set rest node to 5 and max sum to cur sum. We return to the previous call. Now we update cur sum to cur sum plus 6 and pass the next child of 2, that is 6. So root will point to 6. Cur sum will be 6 and count will be 0 as 6 does not have any children. As count is 0, we don't enter the for loop and check if cur sum is greater than max sum. As it is true, we set rest node to root and max sum to cur sum. We return to the previous call. Now we have finished 3 iterations for node 2. So we go to the if part and check if cur sum is greater than max sum. As it is true, we set rest node to 2 and max sum to cur sum. We finish execution for node 2 and return to execution for node 1. Now we add 3 to cur sum for 1 as 3 is the next child of node 1. So cur sum will be 3 plus 3, that is equal to 6. We pass 3 rest node and max sum to max sum util function. Cursum will be 3 and count will be 1 as 3 has one child. Now we run a for loop once, so we update cursum to 3 plus 9, that is 12. Next we pass 9 to maxsum util function. Cursum will be 9 and count will be 0 as 9 does not have any children. As count is 0, we don't iterate in the for loop and check if cursum is greater than maxsum. As it is false, we return to the previous call. We finish iteration for node 3 and check if cursum is greater than maxsum. As it is false, we return to the previous call and finish execution for node 3. Execution for node 1 is also over, and we return max to maxsum function and return rest node's key, that is 2, and that is the final answer. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.